Hello children, today we shall start with our next topic, that is metallurgy. So what is metallurgy? It is the process of extraction of metal from its ore. First, let's see what are metals. What are the physical properties of metals and chemical properties of metals? The physical properties state that metal is sonorous, it has luster, they are malleable, they are ductile. So these are the physical properties of metals. And whereas the chemical properties of metals are metals when reacted with oxygen form metallic oxides. When they react with dilute acids, they give us hydrogen gas. So these are the chemical properties of metals. Where do we find metals? What is the occurrence of metals? Metals is generally found in Earth's crust. Now they are not formed directly as metals in the Earth's crust. It's only gold and platinum, which are inactive metals, are found in their native state. That is in the elemental state. Whereas most of the other metals are found in their oxide, sulfides or carbonate states. They are found in the Earth's crust. Then we also have some chloride metals, metal chlorides, which are found in the sea or in salt lakes. So they are found in the Earth's crust, sea and salt lakes, or if it's an inactive metal like platinum and gold, only then it is found in its native state. We have to see one more term, that is minerals. What is a mineral? So mineral is naturally occurring compounds of a metal. So when the metal naturally occurs, in which state it is? It is a metal carbonate, is it a metal chloride? So that is called as a mineral. So the picture that we can see is a mineral of bauxite. So it's a bauxite ore. Aluminium is extracted from bauxite. Now what's the difference between an ore and mineral? So an ore is a mineral which contains the metal in such a quantity, and from that we can use it for commercial purposes. So when minerals contain sufficient amount of metal in it, that metals can be used for commercial extraction, such a mineral is called as a ore. So all the ores are minerals, but all minerals are not ores. These are the ores that we see of bauxite. These are the various grade of bauxite that is used for extraction of aluminium. Common ores of iron. Let's see common ores of iron. That is hematite. Then we have magnetite. We have siderite, limonite and pyrite. So these are the ores of iron. So when we want to extract iron, one of these ores is taken and then it will undergo different processes to get iron from it. Now let's see the common ores for aluminium. The most common one for that is bauxite. Bauxite is the most widely used ore of aluminium. But we also have cryolite, feldspar and china clay. Cryolite, feldspar and china clay, of which bauxite is most widely used and it is one of the cheapest one. So it is economically viable to have a bauxite ore for aluminium. The common ore for zinc is zinc blende, calamine and zincsite. So these are the ores for zinc. Now how is metallurgy, how is the process go on? So this is a picture image of a mine that we can see. So wherever we have a mine rich in a particular ore, so equipment is used for just collecting all the stones, collecting all those rocks which are rich in this ore, which are rich in the mineral, and they are dumped into those trucks and carried. They are concentrated. What is done? Separation of mud, sand from this is done and it is then sent for further processes. So after various other processes, pure metal is extracted from the ore. So it is from the mine to the pure metal This process, all the processes that come in between mining to preparing of pure metals, is called as metallurgy. Now, I like you to note that the syllabus, that is 7.4 to 7.8 of your textbooks, has been reduced for this year, 2020-2021. So the children giving exams this year will not have the portion that will include stages involved in extraction of metals. But yet we will just see them in very short and quickly. For that, first we need to see activity series of metals. It's very important that we know the activity series of metals. Depending upon the activity series of metals, different metals have different type of extractions. If you take sodium and potassium, they are very, very active metals. So the processes that are followed for the other metals may not be applicable to sodium and potassium. So sodium and potassium compounds will generally have to undergo electrolysis for a separation or for extraction of the metal. The other metals, they have a particular way. The metal will be first purified, the ore will be concentrated. After that, after concentration of ore, there will be different chemical processes, different physical processes, and finally you get some pure metal. And for electro-refining, electrolysis process will be used. And the metals like gold and platinum will have very less procedures to undergo as compared to the others. One of the steps that goes for concentration of ore, that is hydraulic washing. So what happens in hydraulic washing? If the ore particles are heavy, they are made to pass through a groove on a belt. So the heavier particles of ore get stuck onto the grooves, and the impurities which are lighter, they will flow away. So this is how the ore is concentrated by hydraulic washing. Then we have one more process called as filtration. So compressed air is allowed to pass through a pipe that is in the center of the container, and it is mixed, the container is mixed with water and pine oil. What happens if the ore is of sulfide? So it's very light in weight. Compared to that, the impurities will be more heavier. So the impurities which are heavier will sink down, and the light ore particles will be carried by the froth bubbles up to the surface, and it will be separated. So this process is called as froth flotation. So here we can see the top layer that consists of the ore is easily separated into another vessel. This process is generally used for purification of metals like copper, lead and zinc. Then we have one more separation technique, that is magnetic separation. This is used only for substances that are magnetic in nature. So there is a traveling belt on two magnets which is rotated, and the ore is left over it. So the particles that are magnetic, since they get attracted to the magnets that are placed in this wheel here, they will be attracted to this side of the container and fall into the container which is closer to the magnets, whereas the non-magnetic substances will fall up into the next container which contains non-magnetic substances or particles of the ore, non-magnetic particles of the ore. So we also have some chemical processes like slagging and leaching. In slagging, extra impurities of silica are removed. Leaching is a process that is also used for removal of iron oxide impurities from bauxite. So this leaching is also present for purification of aluminium ore. So in this process, what happens? The method of converting a metal into its soluble salt. So it's added, any chemical is added with which we can convert the ore into a soluble salt, and thus the insoluble impurities are removed from it. Then we have methods of conversion of ore to oxides. In that we have roasting, calcination and smelting. So roasting is heating in open air. So what happens when it is heated in open air? When it is heated in open air, it is treated with oxygen and hence sulfur dioxide is given out. So the ore, the sulfide ore is converted into a oxide ore. Sulfide ore gets converted into an oxide ore. The next process is calcination. This is also heating, but it's heating in presence of a closed, it is heating in the presence of a closed environment. So that is in absence of air. So there is heating, but it is in the absence of air. So this process of heating in absence of air to remove out carbon dioxide, in this case, to remove out the carbon dioxide and get a, finally what we want again, we want that is oxide ore. So we want the oxide, metallic oxide. So to get the metallic oxide, it is heated in a closed condition when they are carbonate ores. So this is a process called calcination. Then we have a process of smelting where it is heated and treated and separated so that oxygen is the only other element that is present along with it. Here we have one more process called as smelting. Then we have some methods for reduction of this metallic oxide. So in the previous step, we are converting the metallic compounds into metallic oxides, and now the process of reducing the metallic oxide into the respective metals. That could be either by reducing agents or by electrolysis or by thermal decomposition. The reducing agents could be carbon or carbon monoxide, so which reduce the metals to give us the pure metals in this case. Okay, so we get the metals by using reducing agents, or we can have a process of electrolysis. From aluminium onwards, the metals from aluminium onwards, we need to use electrolysis as a process for separation of aluminium from aluminium oxide. So to separate aluminium from aluminium oxide, okay, we'll have to have an electrolysis process. We'll have to separate it using electrolysis process. It cannot be done by a reducing agent. Or there is thermal decomposition. So where the elements are very lower in the activity series, those compounds can be heated to give the corresponding metal just by heating, just by thermal decomposition. Now this is the topic that is there for your exam. This is there for your syllabus. So the topics that we discuss from 7.4 to 7.8 will not be there for your exams. Now let us see extraction process. The extraction of aluminium is also called as the Bayer's process. In the first step, finely powdered bauxite ore is treated with sodium hydroxide to give you sodium metaaluminate and water. This process is called as leaching. The process is also called as leaching. So what we discussed in the leaching process, a powder will be, or a powder or a compound will be converted into a soluble salts to remove the insoluble impurities. The next step is the filtrate containing sodium metaaluminate and sodium silicate is diluted with cold water and stirred with a small amount of aluminium hydroxide, which acts as the seed. This causes precipitation of aluminium hydroxide, but the impurity of silica remains in the solution. So the next process, first was we converted it into a soluble salt, that is sodium metaaluminate, and now it is undergoing a process of seeding. What is process of seeding? They are going to build up the crystals of aluminium hydroxide. So seeding is building up, growth. So that process will take place here. Then aluminium hydroxide is separated by filtration. The precipitate is washed and ignited to get pure aluminium oxide, also known as alumina. So the next step is filtration. After it is filtrated, the precipitate is nicely washed and it is ignited to get pure aluminium oxide. So what we get, the filtrate is shown down in the figure below, and from that we will get alumina, which is pure aluminium oxide, also called as alumina. The next step is the Hall-Heroult process, that is the electrolytic reduction of alumina. What is alumina? That is aluminium oxide, Al2O3. So what is the next process now? We want to separate oxygen from aluminium. But as we have already seen in the earlier slide, that aluminium oxide cannot be separated by reducing agents or by heating. So it has to undergo the process of electrolysis. Now in the process of electrolysis for alumina, alumina is the source of aluminium. Cryolite is used to lower the fusion temperature. Alumina, if you heat it and you want to melt it, the temperature will be around 2050 degrees Celsius. But if you add cryolite, the fusion temperature comes down to about 950 degrees Celsius. So that is why cryolite is used to lower the fusion temperature. We also have fluorspar, which is used to increase the electrical conductivity. Like we have finished the chapter electrolysis. So we know whenever electrolysis process is going on, we need some electrolyte. And the electrolyte is required for thermal conductivity. For electrical conductivity. And fluorspar is used for electrical conductivity. So this is exactly how it looks in a factory where the Hall-Héroult process is taking place. These are the rectangular tanks in which the electrolysis process takes place. Okay, let's see it diagrammatically so we will understand. Okay, so the same rectangular tank, and we can see some bars are inserted in that. So the bars which are inserted are actually carbon rods, which are the anode for the electrolytic cell. So the whole rectangular tank is a electrolytic cell. The carbon rods, which you can see inserted in the pink color solution, here it's shown in a pinkish color solution. So they are the anode rods, and we have the tank which has a carbon lining which acts as a cathode. So both the anode and the cathode are made up of carbon. The anode is carbon rods, whereas the cathode is the carbon lining for the rectangular rectangular tank. There is an outlet for aluminium. So once the process of electrolysis takes place, and pure aluminium will be attracted to cathode, which is the tank, which is the base of the tank and also the sides of the tank. So aluminium will get settled to the bottom of the tank, and hence an outlet for pure aluminium to come out is made over here. Okay. Let us see the reactions that take place, the electrolytic reactions. At cathode, aluminium ions add up electrons to give pure aluminium metal. So at the cathode, that is at the base of the tank, we get the pure metal. And what happens at anode? At anode, reaction takes place that oxygen ions come, they lose electrons, and oxygen gas is given out. There is also one more thing. We say that powdered coke or powdered carbon is put on top of the tank. That is used so that the heat is not lost and the whole alumina plus fluorspar and cryolite remain in a molten state. So sometimes there is that powdered coke which is added on the top of this electrical unit. Aluminium is used for making utensils, frames, speedboats, aircrafts and automobiles. It is used for power transmission as it is lighter than copper and it is a good conductor. Aluminium foils are used for wrapping and packing. Aluminium powder is used for manufacturing paints, used for electrical and telegraph poles. So you see a lot of telegraph poles which have a silvery finish, and that is because of the aluminium powder used in that particular paint. And it is used so that it has a longer life when it is exposed to air, water and rain. Next use of aluminium is it is used for thermite welding of iron of railway tracks. So exactly it looks something like this as it is shown. Iron oxide and aluminium are taken. It is heated. The resultant generates a lot of heat. It's an exothermic reaction. A lot of heat is generated in this, and aluminium oxide is formed and iron metal is reduced. So this iron, which is in molten state, is dropped onto the cracks of the track that can be filled up. So it is used especially for thermite welding of the railway tracks. An alloy is a homogeneous mixture of two or more solids. The properties of the individual metal is different from those of its constituents. Some alloys have high resistance to corrosion. Some are harder. Some are poor conductors. So as we have seen in our previous videos, what are alloys? Alloys are two or more solid metals which are melted below their melting point and then mixed. We also have alloys where some non-metal like carbon could be mixed into it. And we can also have some alloys made up of mercury. Mercury is a metal in liquid state. So the alloys of mercury are called as amalgam. The alloys of mercury are called as amalgam. Now let's see some types of alloys. So the alloys of aluminium, the first one is dural. It's also called as dural. It's dura aluminium. So dura-aluminium. It is lighter than steel and nearly as strong as steel. It consists of aluminium 95%, copper 4%, manganese 0.5% and magnesium 0.5%. It is used for making airplane parts and bodies of ships as it is light and corrosion resistant. So the alloy of aluminium is used to make dural, which is used for making light parts of aeroplane, ships, and it is corrosion resistant. Means if you see an aircraft is exposed to moisture, rain, even the ship body is continuously in water. So it has to be corrosion resistant. The metal has to be corrosion resistant. Then let's see alloys of aluminium, the other one, that is magnesium. It is light but it has superior strength, so it's an extra strong material although it is lightweight. It consists of aluminium, maybe it will be from 85 to 99%, so we can have a different variation here. So anything above 85% to 99% of aluminium and the remaining part of it will be magnesium, that is either 15 to about 1%. This is used for making automobile parts, balance beams and light instruments. Next we have alloy of iron. So one of the main alloy of iron which we must have used in our everyday life is stainless steel. So how is stainless steel prepared? It is prepared with 73% of iron, 1% of carbon, 18% of chromium and 8% of nickel. So the presence of chromium and nickel gives it the silvery shiny finish. So it also consists of carbon which has to be noted. So the amount of carbon present in the steel will define the quality of steel. So we have different qualities of steel. So the amount of carbon present in it defines the quality of steel. And why do we use steel? It is used for making blades, knives, automobile plates, automobile parts, utensils, food machinery and laundry machines. Now let us see alloys of copper. An alloy of copper is brass. One example here, brass. Brass is made up of around 60 to 80% of copper and the remaining consists of zinc, that is 40 to 20%. So 60-40 you can say. It could vary from 60-40 to about 80-20%. It is used for making cooking utensils, condenser sheets, pipes, hardware and ornaments. The next alloy of copper, it is bronze. Must have heard of bronze as in bronze medal. Okay, so how is it made? It is made from copper and tin. So when you mix copper and tin, and copper should be in the ratio of maybe 75 to 90%. So if you have around 75 to 90% of copper and the remaining part of it is tin, what we get, the alloy will be called as bronze. It is used for making coins, statues, hardware and utensils. So it is used for making different statues, decorative items, and also, as we know, it is used for making medals. The next important alloy is that of tin, and that is called solder. Solder is also called as fused metal. Solder is also called as fused metal. It's an alloy of the metal tin. It consists of 67% of tin and 33% of lead. Where do we use this solder? It is used as a it is used as a joining wire. You must have heard whenever electricians are working or there is some kind of electronic work happening, small devices are there. If any part needs to be soldered, that is joint, fused. If a metal needs to be fused, maybe metal wire, metal plate, so that time we use soldering. So it is, now why we use solder? What is the speciality of solder? It has a very low melting point and it is used to join the wires and resistance. Resistances are different parts of electronic components or electronic or electrical components. So we have resistances and wires which can be joined using a solder, that is an alloy of tin. It's also called as fused metal. So let's summarize everything that we have covered in this chapter. So first we have seen minerals and ores. Then it was extraction of aluminium. Then was the Bayer's process. We then saw the Hall-Héroult process, alloys composition and their uses. So I hope that all the topics taught in this chapter are clear to you. Thank you.